Good morning to all of you. Actually, my previous session was not closed, so there is a delay. Yes, sir. First point, for your examination, you have only the general organic chemistry. In general organic chemistry, I am making 3 videos. Each video is 10 minutes duration. There are about 45 questions I am doing. If you look at those 45, 50 questions, you will be getting 100 marks in upcoming exam. Now, I will be seeing how many of you will get 100 marks. Okay.
Sir, what you told, sir?
I said only next upcoming exam is in the general organic chemistry. In general organic chemistry, I am uploading 50 questions. If you
on YouTube, sir.
On YouTube. If you watch these YouTube lectures, 50 questions, you will get 100 marks out of 100.
Sir, when you are uploading, sir, that 50 questions?
I will be uploading before tomorrow morning. Because tomorrow there is no class.
Filled with shit for the strong-willed. When the world gives you a raw deal, set you off till you scream, piss off, screw you when it talks to you like you don't belong.
There is someone named dot.
Like something's in your mitochondria, because it latched on to you like.
Yes, sir.
Why are you getting agitated? First of all, you see, good morning. First of all, let us learn to be peaceful. Somebody will upload some noise. Okay, let him upload what is there. Okay. At the end of the day, in the name of Allah, we should not have enmity or anger on anybody. You understand? Let's not get excited. I wish that my students have ability to excuse others and accommodate everyone. Don't get excited. Okay, sir. I have seen so many mothers. If the boy slips and falls down, mother gets irritated, scolds and beats the child. Already this fellow has fallen down and crying. Should you beat again? I don't know. Therefore, allow the people to make noise, let them make. Don't get excited. Coming back. Sir, today we are going to do one very important thing called valence shell electron pair repulsion theory. What is the name, sir? This is a good theory that explains the shapes of molecules which your octet rule or Lewis dot formula cannot do. It is very important to know the shapes, sir. Yes, sir. So, the valence shell electron pair repulsion theory is a good theory that explains the shapes of molecules that cannot be done by Lewis dot formula. So far, you have learned how to write Lewis dot formula. Have you learned, sir? Hello?
Yes, sir.
Hello? I have not muted any of you. Any of you can speak. Sir, yes, have we learned how to write Lewis dot formula?
Yes, sir. Yeah.
Very good. Now, the Lewis dot formula Lewis theory cannot explain the shapes of molecule. Knowing the shape of a molecule is very important because properties can be explained in terms of shape of a molecule. Well, Vesper theory is a simple theory developed by Gillespie and Nyholm that explains the shapes of molecule. What is this theory?
Sir, but this theory was also failed, no, sir?
This theory can explain the shapes of molecule, but this theory has limitations.
It
Definitely you
can't show
have hybrid.
angle.
See, human beings are evolving. First they were walking. Then they learned how to use a cycle. Then they have developed motorcycle. Then they have developed car. Then they have developed helicopter and aeroplane. Because you have discovered aeroplane, have you stopped walking?
No, sir.
No.
So walking is there, cycle is there, scooter is there, car is there, aeroplane is also there. And you see, like that, the concepts have developed. So let us not reject anything. Vesper theory is an idea that tells you about shapes of molecules. It has limitations. Okay. Okay. Sir. Now, according to Vesper theory, the shape of a molecule depends on the number and nature of electron pairs a central atom has. The Vesper theory is applicable for simple molecules which have only one central atom. If you have a giant molecule like C75H152, it has so many central atoms, your Vesper theory cannot say anything. Your Vesper theory is for simple molecules where there is one central atom that is bonded to certain number of atoms like AB2, AB3, AB4, AB5, AB6, AB7, etc. Now the A is a central atom. The central atom is bounded to two B's. It can be like CO2. A is bound to two oxygens. It can be like BCl3. A is bound to three Cls. It can be like CH4. Sir, what type of molecule IF7 is? Can you say? IF7 is AB7 type molecule. What type of molecule BCl3 is?
AB3.
AB3. What type of molecule CH4 is?
AB4.
AB4.
What type of molecule SF6 is?
AB6.
E6.
Okay, it is so obvious. Sir, A, suppose it has two electron pairs and both are used for bonding, then I can say it is AB2 type molecule where there are no lone pair of electrons on A. Suppose A has three electron pairs, out of which only two it is using for bonding. One electron pair is simply sitting on A. Then I call it as AB2E type molecule, where E is called lone pair.
Baffling, malevolent as I've ever been. Head is spinning, this medicine screaming, medicine.
Thank you so much for entertaining in between. Inshallah, we are going ahead. Sir, AB2 has one lone pair, then I call it as AB2E1. Suppose I have two Bs and also two lone pairs. What type of molecule it is, sir? What type of molecule it is? Hello?
AB2E2.
Perfect. Suppose I have A has two Bs and what type of molecule it is?
AB2.
AB2E3.
Now I would say that a central atom can have two types of electron pairs, bond pairs and lone pairs. Bond pairs are busy in binding A with other atoms, whereas lone pairs are simply sitting on A without any work. And now the shape of a molecule is decided by nature of repulsions. The repulsions are lone pair repulsions are very serious because fellow who has no work will cause a lot of disturbance. Lone pair has no work, simply sitting with no work. So the repulsions between lone pair is more than repulsion between lone pair and bond pair, which is more than repulsion between bond pair and bond pair. Fellows who are busy in doing their work, they don't cause disturbance to others. So the order of repulsions, lone pair is more than, lone pair bond pair is more than, bond pair. Are we very clear about it, sir?
Yes, sir.
Sir, JL 4107, sir.
It's okay, man. Let's not waste our time because of what somebody is
That's
saying.
everything.
Never mind. Never get excited. You see, it's okay. Stay cool. Okay. Now, somebody who is getting disturbing will get importance only when if you are getting disturbed. If you are not getting disturbed, nothing will happen. Okay. Let's decide not to get disturbed. Now, I was talking to you about, look here. According to Vesper theory, the shape of a molecule
Written should have been dead a long time ago. Liquid Tylenol, gelatin, sneak my skeletons.
According to Vesper theory, the shape of a molecule is decided by the number and nature of electron pairs present on the central atom. There are two types of electron pairs. Number one is lone pair, number two is bond pair. The shape of molecule is such that the repulsions between these electron pairs are minimum. They are minimum if they are as far away as possible. Therefore, the shape of a molecule is decided by the number and the nature of electron pairs on the central atom. There are two types of electron pairs, lone pairs and bond pairs. The order of repulsion, lone pair is greater than, lone pair, bond pair is greater than, bond pair. If you know this, now you can arrive at this shape. Suppose you have A. It is bound with two B's. In how many ways you can arrange? In how many ways you can link A with B, sir? Either you can link like this or you can link like this. Only two possibilities. Yes or no? What is this shape
Yes, sir.
called? What is this shape called?
Linear.
What is this shape
Linear.
called?
180
What is
degrees.
this called? What is this called?
Triangular.
Screw it, to hell with it. I went through hell with accelerants and blew up myself again. Volkswagen.
Sir, Kauta meeting will come again.
No problem, sir. Okay. Sir, AB2 type molecule can be linear or it can be bent. If the bent is too much, it is called V shape. Okay. Now suppose AB3 molecule is there. A is linked to three B's. If they are as far away as possible, they are separated by 120 degrees. What is this shape, sir?
Trigonal
What is
Trigonal planar.
trigonal planar?
Planar.
All are in one plane. Suppose, sir, A is having four fellows bonded. They want to be as far away as possible. What is this shape, sir?
Tetrahedron.
Tetrahedron. And this angle is 109 degrees 28 minutes. The distance between this point and this point, this point and this point, this point and this point is identical. A very stable structure, AB4 tetrahedral. Suppose A is linked to 5 fellows. 1, 2, 3, 4, 5. These are like trigonal planar at 120 degree separation. These are lying above and below. What is this shape, sir? What is this shape, please? What is this shape? Hello. I will draw again. What is this shape, sir? I draw again. I don't know. You are not able to see this shape. What is this shape? Hello, what is this shape?
Triangle.
So if I put here a point, what is this shape?
Pyramid.
Triangular pyramidal.
Trigonal
Triangular
pyramidal.
pyramidal.
Trigonal pyramidal.
Triangular.
What is this shape? Trigonal bipyramid. What is it, sir?
Trigonal bipyramid.
All of you practice writing trigonal bipyramid structure. This is one line. Here you have B, B, here A. You try to write a triangle. If you join all the ends, you get the shape called trigonal bipyramid. Is it difficult to draw? Hello?
No, sir.
AB5 can be drawn like this.
Dribble Jam Rap Olympics 97 freak Nick. How can I be down me in Bazaar in Florida?
Sir, log the meeting, sir. He will come again.
I have removed him. Now I will not admit anybody. I am closing admissions.
Yes, sir.
Sorry, because I have allowed a lot of time. Now nobody will be admitted, even if you want. I am locking the meeting because we have no time. Yeah. I am locked the meeting. I will not admit anybody now. Sorry, that's enough. Because already it is late, I can't help. Sir, AB5 type molecule can be trigonal bipyramid. What about AB6? This is A. What is this shape, sir? What is this shape? I am drawing again. One line. This is A, B, 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 B. What is this shape? If you join the ends, you see.
Sir, square bipyramidal.
Let us see this shape. What is this shape, sir?
Square bipyramidal.
It is square bipyramid or octahedra. Okay, sir. So if you have AB2 with no lone pairs on central atom, it is linear. AB3 with no lone pairs on central atom, trigonal planar. AB4 with no lone pairs on central atom is tetrahedral. AB5 with no lone pairs on central atom is trigonal bipyramid. AB6 with no lone pairs on central atom is octahedral. AB7 with no lone pairs on central atom is pentagonal bipyramid. Okay, sir. You should know this. If you are having a central point to which two sticks B's are linked, if you want them to be as far away as possible, it should be linear.
Sir, AB7, please tell name.
AB2 is linear. AB3 is trigonal planar. AB4 is tetrahedral. AB5 is trigonal bipyramid. You know how the trigonal bipyramid? It is like this. You can draw it, right? Yes. Octahedral you can draw. AB7 is pentagonal bipyramid. Here you have to draw a pentagon. In the center, up, down. You join all the ends. So don't worry about this. It is trigonal, pentagonal bipyramid. Okay. Okay, sir. Hello.
Yes, sir.
These are all the molecules where central atom has no lone pairs. All electrons are used in bonding. Let me look at examples. Beryllium has how many valence electrons?
2.
Boron and aluminum have how many valence electrons?
3.
Carbon, silicon, tin, lead, etc. have how many valence electrons?
4.
Nitrogen, phosphorus, arsenic have how many valence electrons?
5.
5.
Oxygen, sulfur, selenium have how many valence electrons?
6.
6.
And fluorine, chlorine, bromine, iodine, they have.
7.
Noble gases like xenon have.
8
8.
valence.
So you should remember this list. If you want, you can also remember thallium. Thallium also has 3. Boron, aluminum, gallium, indium, thallium. So you should know the number of valence electrons an atom has. If beryllium is using both its electrons in making 2 bonds in BeCl2. BeCl2 is Ab2 type, no lone pairs. It is linear. Bond angle is 180. Similarly, if you look at boron, PCl3, boron has 3 electrons. It has used all the 3 electrons for bonding. It is BCl3 trigonal planar. Similarly, if you have carbon, CCl4, SiH4, when the central atom is using all the electrons for making enough bonds, if it is AB4, what is its shape, sir?
Tetrahedral.
Trigonal.
Tetrahedral.
I already gave the table here. AB2 linear, AB3 trigonal planar, AB4 tetrahedral, AB5 trigonal bipyramid, AB6 octahedral, AB7 pentagonal bipyramid. For example, let us take oxygen. Sorry, let us not take oxygen at this point of time. Let us take sulfur. SF6. Sulfur has how many electrons in the valence shell? Hello, how many?
6.
6.
How many bonds it is making?
6 more. 6.
So SF6 is AB6. What is the shape?
Octahedral.
Octahedral. So all regular geometries are very stable and they make stable molecules. Sir, please notice, whenever oxygen is there, it makes 2 bonds. In CO2, carbon is making how many bonds?
2
2
bonds.
bonds. 4
Nah.
bonds. 4
Each
bonds.
4
oxygen
bonds.
makes
4 bonds.
4 bonds. Forget about bonds now. How CO2 is looking like? It is looking like AB2 molecule. Yes or no?
Yes, sir.
And carbon has how many valence electrons?
4.
4.
So in CO2, carbon is using all the 4 electrons because each oxygen uses 2 electrons to make a double bond. So in CO2, carbon, all 4 electrons are utilized for bonding. There is no lone pair. CO2 is looking like AB2. All AB2 type molecules with no lone pairs are linear in shape. Are we very clear about it?
Yes, Yes, sir. sir.
What about SO3? Sulfur has how many valence electrons?
6.
6. 6.
In SO3, all the 6 electrons are utilized in bonding. So SO3 is looking how?
AB3.
Trigonal planar.
Trigonal
It
planar.
is looking
Trigonal
like
planar.
AB3. So it is trigonal planar. So if they give you any simple molecule, you can tell its a shape. Now the problem comes when there are lone pairs. Sir, I have SnCl2. Now tin has how many electrons in the valence shell?
4.
4. Out of 4, it is using how many for bonding?
2.
2.
So it is using 2 for bonding. Remaining 2 are there as a lone pair. Can you see?
Yes,
Yes,
sir.
sir.
Therefore, I write SnCl2 as Ab2E type molecule. Are we very clear?
Yes,
Yes.
sir.
Yes, sir.
Now, Ab2E means how
Yes,
many
sir.
electron pairs are there?
One lone pair.
There is one lone pair, there are 2 bond pairs, there are 3 electron pairs. Yes?
Yes,
Yes,
sir.
sir.
How many electron? Generally, if A has 3 electron pairs, they must be arranged like trigonal planar. Yes or no?
Yes.
Yes, sir.
Out of these 3, this is a bond pair, this is a bond pair, this is a lone pair. Lone pair will not contribute anything to shape. Only thing it causes is it causes disturbance. It repels the bond pairs. Due to the lone pair, now AB2E type will have bent shape. So SnCl2 has what shape?
Bend shape.
Bend shape.
Bent shape. Let us look at. Let us consider H2O. Oxygen has how many electrons around it in the valence shell?
6.
6.
6.
6. You can see here, oxygen has 6. Now, out of 6, how many bonds it is making?
2.
2.
2.
So it is using 2 bond pairs. 2 electrons are used for making bond. How many are remaining?
2
2
lone.
lone pairs are remaining.
2 lone pair.
If 2 are used for bonding, 4 electrons are remaining as 2 lone pairs. Yes?
Yes, sir.
Yes, sir.
Yes?
Yes, sir.
Therefore, H2O is Ab2E2 type molecule. Yes?
Yes, sir.
Yes.
Yes, sir.
Now, how many electron pairs are there? 4 electron pairs. Out of 4, 2 are bond pairs, 2 are lone pairs. Okay?
Yes, sir.
Yes, sir.
If A has 4 electron pairs, how all the 4 electron pairs are supposed to be arranged? Like tetrahedron.
Tetrahedral.
In the tetrahedron, only 2 are bonded and remaining 2 are sitting with no work. Now the lone pair repelled too much, so they force these 2 fellows to come close. Therefore, what is the shape of this? What is the shape of this?
Bent shape.
And
It is so much bent, actually it is called V shape. Yes or no?
Yes,
yes,
sir.
sir.
So Ab2E2 type molecule is really bent. Originally, the electron pairs must be tetrahedral, but in the tetrahedron, 2 positions are lone pair makes it bent and V shape. Right?
Yes,
Right?
sir. Yes, sir.
Now let us take another case. Xenon has how many electrons around it?
8.
8.
Out of 8 in HCF2, how many electrons are used for bonding?
2.
2.
2.
If 2 are used for bonding, how many are left unused?
6.
3 lone pair.
6.
It means 3 lone pairs. So HCF2 is Ab2E3 type molecule. Yes.
Yes,
Yes,
sir.
sir.
Now Ab2E3 type molecule, A has how many electron pairs?
5.
5.
If there are 5 electron pairs, they are supposed to be like trigonal bipyramid. Yes? Yes?
Yes,
Yes,
sir.
sir.
In the
Yes,
trigonal
sir.
bipyramid, there are only 2 bond pairs. And the lone pairs want to be as far away as possible at 120 degrees in equatorial positions. These three lone pairs are at 120 degrees and they try to be as far away as possible. Now, how AB2 is looking like with three lone pairs? How it is looking like?
T shape.
Linear.
It is just linear. It is just linear. The lone pairs are cancelling each other at 120 degrees. So AB2E3 type molecule has which shape?
Linear.
You
Linear.
should think, you understand? It is linear. Are we very clear on this?
Yes, sir.
So now
Yes, sir.
we have
Yes, sir.
come to an idea. AB2 is linear. AB2E type is bent. AB2E2 is V shape. AB2E3 is again linear. Yes, sir?
Yes,
Yes,
sir.
Are we clear on this? Example for AB2 is BeCl2. Example for AB2E type is SnCl2. Example for AB2E2 is H2O or SCl2. Example for AB2E3 is what, sir?
XCF2.
Now let us take a case of AB3 type. What is the AB3 type shape? Trigonal planar. Yes, sir? Are we very clear?
Clear, sir.
Yes.
BCl. Sir, if you are looking at NO3 minus, nitrogen, how it is looking like NO3 minus? Forget about charge. How it is looking like?
AB3.
AB3. Now let us look at the electrons. Nitrogen has how many electrons in the
Five.
valence
Five.
level?
5.
And because there is a
Five.
minus charge, you have to add extra electron. Now, how many electrons nitrogen has?
6.
Remember, whenever oxygen is there, oxygen uses 2 electrons to make a double bond. Therefore, there are 3 oxygens. How many electrons are used for bonding?
6.
6.
So, all the 6 electrons are used for bonding. Nitrogen has no lone pair. So, NO3 is actually AB3 type with no lone pairs. So, what is the shape of NO3 minus ion?
Trigonal planar.
Are we very clear about that?
Yes, sir.
Clear, sir.
Now, let us look at carbonate ion. Forget about charge. How carbonate is looking like?
AB.
AB3.
Now, carbon has how many electrons?
4.
Because there are 2 negative charges, I have to add 2.
6.
How many electrons? 6. How many are used for bonding?
6.
Therefore, carbon has no lone pairs. It is simply AB3 type. So, carbonate ion is also trigonal planar.
Planar.
Yes.
Yes, sir.
Also notice, the number of electrons in carbonate ion and nitrate ion is same. Ions which have same number of electrons are said to be isoelectronic. Isoelectronic fellows have same shape and same bond angles. So both carbon and nitrate are of same shape, trigonal planar.
Yes,
What
sir.
about SO3? Sulfur, how it is looking like?
AB3.
AB3.
Now sulfur has how many electrons?
6.
6.
6.
How many are used in bonding?
6.
6.
So it is AB3 trigonal planar. Okay, sir.
Sir.
Yes, sir.
Now let us look at NH3. How it is looking like?
AB3.
Now nitrogen has how many electrons in the valence level?
5.
And how many are used for bonding?
3.
3.
So how many electrons are left?
2.
2.
It means 1 lone pair.
1 lone pair.
So ammonia is AB3 type molecule. Now A has how many electron pairs around it?
4.
If there are 4 electron pairs, what should be the arrangement?
Tetrahedral.
In this tetrahedron, only 3 are bond pairs. One is lone pair simply sitting idle. Only it can cause repulsion. Now, what is the shape of this AB3?
Bent shape.
No,
Trigonal planar.
no.
Tetrahedral.
These are 3 B's. B, B, B. This is A.
Trigonal pyramidal.
It is trigonal pyramid. It is not plane. The 3 B's are in one plane. B, B, B. And one A is in a different plane linked to all the B's. This is called trigonal
Pyramid.
pyramidal. It is a pyramid. Yes or no?
Yes, sir.
Yes, sir.
So ammonia is AB3A type molecule which has pyramidal shape. Okay, sir? Okay.
Yes.
Let us look at ClF3. How it is looking like?
AB.
AB3.
AB3.
Now Cl has how many electrons?
7 electrons.
How many are used for bonding?
3.
3.
How many are remaining?
4.
Means how many lone pairs?
2 lone.
Sir, we can't listen your voice.
AB3A2, is it clear?
Yes, sir.
Yes, sir.
Now A has how many electron pairs around it?
5.
5.
5.
If there are 5 electron pairs, what is the ideal arrangement?
Trigonal bipyramidal.
In this
Trigonal
trigonal bipyramid, the lone pairs want to be as far away as possible at 120 degrees. So these are B's. What is the shape, sir? You just turn it.
T shape.
T.
What is the shape?
T shape.
It is T shape. So ClF3 has what shape?
T shape.
There are 5 electron pairs, out of which 2 electron pairs are lone pairs at equatorial positions, and 3 electron pairs are bond pairs. They are making T shape. Is that very clear?
Yes.
Yes, sir. Sir, can we go to our maths class?
So this way you have to develop the shape. Now I am concluding. The molecules according to Vesper theory can be simple molecules with no lone pairs like these types, and they have regular geometries called linear, trigonal, planar, tetrahedral, trigonal bipyramid, octahedral, pentagonal bipyramid. They can also be like AB to E1 type, AB to E2 type, AB to E3 type. This is a bent, V shape, linear. AB3 is pyramidal. AB3E2 is what shape, sir?
T shape.
T shape. AB4E1 is what shape, sir? You should think AB4E means there are 5 electron pairs. If A has 5 electron pairs, they must be like trigonal bipyramid. In trigonal bipyramid, you are saying it is AB4E type. That is one lone pair. One lone pair will go to equatorial position. Now, these are B's. Now, what is the shape of this? You can see these 2 B's are like this. And these 2 B's are like this. What is this shape, sir? Hello, what is this shape?
Seesaw shape.
It is
Pie
called
shape.
seesaw. Can you see that really? Can you see it, sir?
Yes.
Hello? SF4. Sulfur has how many electrons?
6.
How many bonds it is making?
4.
4.
How many are remaining?
1 lone.
That is one lone pair. AB4E. AB4E has what shape?
Seesaw.
You should see it actually. Don't try to by heart. You should see it. Are you seeing it? Are we together?
Yes, sir.
Therefore, AB4E type molecules have seesaw shape. Yes, sir? Yes, sir?
Yes,
Seesaw.
sir.
What about AB4E2 type? Can you think? AB4E2 means how many electron pairs on central atom?
6.
If there are 6 electron pairs, what is the shape?
Octahedral.
In this
Octahedral.
octahedral, 4 B's are there and 2 lone pairs. If you forget about the lone pairs, what is the shape?
Square.
Square planar. Can you see that, sir?
Yes.
Can you see it, sir? Now
Yes, sir.
let us look at XeF4. Xenon has how many electrons?
8.
8
How XeF4 is looking like?
AB4.
And now out of 8 electrons, how many are used for bonding?
4.
4.
How many are remaining?
2 lone
4.
pairs.
It means 2 lone pairs. AB4E2. AB4E2 is having what shape?
Square
Planar.
Can you see it really?
Yes.
Yes, sir.
Yes. Now let us look at AB5E type molecule. AB5E type means how many electron pairs?
6.
If there are 6
Six.
electron pairs, what is the shape supposed to be?
Octahedral.
Octahedron. In octahedron, there are 5 bond pairs, 1 lone pair. If there are 5 bond pairs, what is the shape? What is the shape, sir?
Square pyramidal.
Square pyramid. Let us look at BRF5. How it is looking like?
AB5.
Now BR has how many electrons?
7 electrons.
How many are used for bonding?
5 electrons are used.
How many are remaining?
2.
2 electrons.
2
One lone
means 1
pair.
lone pair. So AB5E type is what shape?
Square
Square.
pyramidal.
Square pyramid.
So that is the way to develop the concept of Vesper theory. Therefore, according to Vesper theory, every central atom can have 2 types of electron pairs, lone pairs, bond pairs. The order of repulsion decides the shape of molecule. The electron pairs want to be as far away as possible to minimize the repulsion. So the molecules can be classified as those which do not have lone pairs on central atom. They can be like AB2, AB3, AB4, AB5, AB6, AB7 types. They can have these types of shapes. If the central atom has lone pairs, the lone pair occupies more space and causes distortion. And that brings about variation in the shape. If it is AB2E type bent, AB2E to V shape, AB2E3 linear. If it is AB3E pyramidal, if it is AB3E to T shape. If it is like AB4E, it is C shape, seesaw. If it is like AB4E2, it is square planar. And if it is AB5E type, it is square pyramid, so on. So this is one of the simplest theories that explains the shapes of molecules. Thank you very much. Now, I am going to make 3 videos, as I already said, on
Yes,
the
sir.
GOC. I expect you to watch them because I am spending more than 6 hours to make those videos.
Sir,
About I try to make a video. I don't know whether I can make. I have a lot of commitment. Tomorrow probably is a holiday. Anyway, Saturday, Sunday I don't take. We'll be meeting again on Monday. Try to watch the videos. I will be sending you a link the moment they are ready. Okay. I wish you good luck. I am closing this.
Yes, sir.
Have you enjoyed?
sir,
Yes,
which
but-
type of videos you are making, sir?
I will be making 3 videos on organic.
Send link in group, sir.
And I will 41 group. Sir, have you enjoyed learning the concept of Vesper theory?
Yes, sir.
Yes,
Yes.
sir.
Thank you very much. Hope to meet you Monday. Thank you.